Station, this is Houston. Are you ready for the event?
Houston Station, ready for the event.
William Brooks Elementary School and Buckeye Elementary School. This is Mission Control Houston. Please call station for a voice check.
Station, this is William Brooks Elementary School and Buckeye Elementary School. How do you hear me?
Hello to the elementary schools. Well, I hear you loud and clear, and I'm excited to talk to you today.
Good morning, astronauts. My name is Dr. David Roth, and I am the superintendent of the Buckeye Union School District. On behalf of the Brooks Elementary Bears and the Buckeye Elementary Bobcats, along with our teachers, administrators, and the entire community of the Buckeye Union School District, we wish to extend to you a very special welcome. It is fitting that our students who live in El Dorado County, California, where it is the 150th year of the discovery of gold that resulted in many thousands of men and women migrating into the new frontier of that era, would have the opportunity to speak today with you scientist adventurers who are engaged in a new frontier of discovery for humankind in this era. We are grateful and excited for this opportunity, and I'd like to bring up the first student with Mr. Lee, our school principal, to provide the first question. Thank you.
My name is Emily, and the Brooks Kinders would like to ask, how do you write in space without your paper floating away?
Emily, that's a great question, and that's something that I had to learn when I got here because I had the exact same question. And so I grabbed a couple things to show you how we write. So normally, right here on my leg, I carry this clipboard around, and this clipboard has Velcro on the back, which helps it stick to my pants. These stripes are just Velcro on my pants, so I can always have my clipboard with me. And then we use a clip to keep our paper down. And then when I'm working, I use my pencil that's attached to a lanyard so it doesn't float away. And that way I can make my notes, and then I can stick my pencil back with Velcro onto my clipboard, and I put it right back there so it doesn't float away. And then we also, all over Space Station, have little clips with Post-it notes and pencils on lanyards, so we can do the same thing. So we have to clip our paper down so it doesn't float away.
Okay, go ahead.
My name is Ayla, and Buckeye students would like to ask, what happens when you sneeze in space?
Well, I think the answer to that one depends on what you're doing when you're in space. So if I'm sitting here right now, my feet are constrained, so I'm not going to float away anywhere. But if I wasn't constrained, if I just did this, and I was floating here, and I sneezed, I want you to think about the force that would come out. So it would be actually a force. It would be like a little jet engine, right? Pushing me. That's what a sneeze really is. It's a little jet engine. So if I sneezed, I would actually float backwards from the force of that sneeze. But just like on Earth, we have to make sure we cover our mouth when we cough or sneeze as well.
My name is Yushi, and Brooks first grade would like to ask, how do you know what time of the day it is in space?
Well, that's another great question, because how many times do you guys think that we go around the world every single day? We actually go around the Earth 16 times, which means that every 45 minutes we either have a sunrise or a sunset. So if it was like on Earth and we didn't have a watch on and we just looked outside and we said, okay, we're going to go to bed when the sun goes down and then we're going to get up when the sun comes up, we'd be going to bed like 16 times a day and we'd only be sleeping for 45 minutes. So that doesn't work. Now, we also talk to mission control centers all over on the ground, and some of them are in Houston in the United States. We talk to our mission control in Russia, in Alabama, in Germany, and in Japan, and everybody's on a different time zone. So it also wouldn't work to just pick one of those and go on their time, because then everybody else would be way off, right? So what we do is we actually create days and nights based on what we call GMT, which is the standard time. So it's actually the same time it is in London, England up here. And so we tell the time just by looking at our watches or looking on the computers, just like on the ground. And then all of those centers on the ground, they know what time it is, and we can artificially create day and night. And actually, the lights that we have on Space Station, we can adjust because it's really important that our bodies have circadian rhythms so that we know what time is in the morning, we know when it's time to go to bed. And so we actually adjust our lights to take the blue light out of the lights on station in the evening to trigger our bodies and say, hey, it's evening time. And then at nighttime, we turn off all the lights. And so our bodies can maintain a normal rhythm like on Earth.
Our names are Emma and Aubrey, and Buckeye students would like to ask, how do you sleep in space?
Well, sleeping in space, I want to tell you first a little story about one of the craziest things that happened to me in space, and that was the very first morning that I woke up in space. And so I want you to think about when you sleep really hard and you wake up and it takes you a minute sometimes to kind of remember where you are. Now, imagine that, but you wake up and you're floating. That was one of the most surreal experiences to me. So sleeping and waking up is still pretty fun here. But in order to not float away when we're sleeping, we actually get inside of a sleeping bag that we attach to the wall, and we use kind of clips and bungees, and we just kind of hook ourselves to the wall, and then our arms tend to float up like this when we sleep. So we kind of look like zombies attached to the wall when we're sleeping.
Hi, my name is Evelyn, and Brooke, second grade, would like to ask, what is the weather like in space?
Well, I'm going to answer that two different ways. So there's two kinds of weather that we can think about in space. So there's the weather inside of the space station where we live, and then there's the weather outside of space station, and those are really different. So first we'll talk about inside space station. The engineers on the ground have done an amazing job of creating this space that feels a lot like Earth. So other than floating, our temperatures and our air is almost exactly like we have on Earth. And that's actually because in order to live, we need certain things in our air, like oxygen, right? And our bodies are so used to living on Earth that in order to be comfortable, we have to have very similar temperatures. And so our temperatures are probably just like yours are at home. That's about 70 degrees on space station, maybe just a little cooler. And we can actually adjust that a little bit cooler at night if we want to, or make it warmer during the day. One of the things that a lot of us end up missing actually is breeze, because we don't really have wind in space. And so today when you go outside and you feel a breeze, just think about that's one of the things that I miss. Now, the weather outside is not like the weather that you would think of on Earth. It's not like there's no rains or storms or things like that or wind, because it's a vacuum. There's actually no atmosphere. And so the temperatures get extremely hot and extremely cold, depending solely if you're in the sun or in the shade. And so, when we go on a spacewalk, if we are in the sun or we're in the shade, that temperature difference can be like 300 degrees. And so we cannot go outside. Temperature is just one of the many reasons that we can't go out with our special protection of our spacesuits.
Hi, my name is Nora, and Buckeye students would like to ask, what do meteor showers look like up there?
So our biggest window on space station actually looks back at Earth. So we can't see a lot of the meteor showers that you can see from Earth, because you're kind of looking out and past this. And we're only about 200 to 250 miles above the Earth. And so when we look down, the things that we can really see is when meteors re-enter the atmosphere, because they actually burn up with the atmospheric drag. And you can sometimes catch like a little bit of a fire. It almost looks like a comet would, just coming right into the atmosphere. And so that's kind of the only meteor showers that we can see is actually looking down.
Hi, my name is Genesee, and the Brooks third graders like to ask, what do you do for fun in space, and do you have any toys to play with?
Well, that's another great question, because I will tell you that coming up to space has been like I get to be a kid again, because every day is fun. And I'm telling you, you can do any job, and when you're floating when you're doing it, it makes it even more fun. Like this, look. I can leave the microphone here and talk to you, and maybe I would feel like answering your question upside down. So a lot of times for fun in space, we just figure out how fun it is to float. But we do have other things. So I bet a lot of you like to play basketball. We have a basketball on Space Station. Now, it doesn't bounce really well, and I don't really want to bounce it off the walls because somebody from Mission Control would probably get upset if I broke something. Another one of the fun things that we can do is on the weekends we get a chance to talk to our families, and so we can talk to them on video and see what's going on Earth so we don't miss everything. And of course they like to float around and get tours of the space station. And then one of the special things we do as a crew is that we have a little projector and we can have a movie night, and so everybody comes down, we have good snacks, and we like to maybe watch a movie on Friday night.
My name is Chase, and Buckeye students would like to ask, how do you steer the space station?
So that's another great question. You know, you're probably thinking of an airplane that's going through the air, and then there's a pilot who's moving the controls. That's what I used to do as a pilot. And you move the controls, and then the wings move, and then your airplane moves through the air. And that's not exactly how we're traveling through space. When we travel through space, what we're actually doing is we're kind of in this constant state of falling toward the Earth. And it's the Earth's gravity that keeps us going around in an orbit, in a circle. And so actually, more often than not, we don't actually need to make a lot of adjustments. We don't need to fly, per se, to fly that vehicle through the air. Now, the folks at Mission Control are actually the ones that control where the station's going to be. The big maneuver that we do have to do, and that they calculate, and we do, you know, every few weeks or every month, is called a reboost. Because as we get that little bit of gravity, as we're going around the Earth, we actually move closer and closer to Earth. So if we didn't do anything, we would actually re-enter the atmosphere, which wouldn't be safe because this vehicle is not designed to do that. And so what they do is they program in a series of commands, and we have some thrusters on one side of the space station that light, and it will actually reboost us. We call it a reboost, and it boosts our orbit up into a higher orbit.
My name is Lindsay, and the question Brooks, 4th grade, would like to ask: we know space debris is a major concern. What ideas are being explored to clean up the layers of our atmosphere?
Well, I'm really glad that you're thinking about this question, because this is a question that's going to become a bigger and bigger deal as the years go on and more people start to get involved in space exploration. Being responsible and not creating debris is very important. Like I just talked about, the space station doesn't need to fly in order to maintain a high speed and go around the Earth. Well, that's the same thing if there was a little piece of metal. It can fly extremely quickly around the Earth, and that can be dangerous for the space station and for satellites. If you think about the damage that a rock can cause to your windshield if you're going 60 miles an hour, well, now think about if you're going 20,000 miles an hour. So orbital debris, what is it? It consists of like natural materials as well as human-made debris, like rocket bodies or old satellites that are no longer orbiting the Earth. So debris is tracked. We track it on the ground. So debris is tracked by a system of ground-based radar, telescopes, satellites, and computer models. And right now, currently, there are more than 500,000 pieces of debris being tracked around the Earth, with over 20,000 of those being bigger than the size of a softball. So that is a big concern. Some orbital debris in low Earth orbit naturally burns up in the atmosphere, so that gravity pulls it closer and closer to the Earth's atmosphere, and then as it hits that atmospheric drag, the heat created actually causes that to burn up. However, a lot of it can stay in orbit for a long time. And so right now at NASA and some other places, we are designing possible solutions to remove this orbital debris. And some of the most common proposals are maybe sending a spacecraft with tethers or nets to try to capture some of it. And here on the space station, our ground teams monitor these pieces of debris because it is very important that we don't collide with one of those pieces of debris. And so we can, that's the other time that they will maneuver the space station with thrusters, is to move us out of the way of any debris that they're tracking.
My name is Braden, and Buckeye students would like to ask, what was the most fun part of your training of becoming an astronaut?
Well, I tell you, there's a lot of fun parts of this training. It is a lot of hard work, but there are definitely moments where you sit back and you realize how fun what you're doing is. For me personally, I enjoyed the spacewalk training. We have this really big swimming pool at NASA. It's called the Neutral Buoyancy Lab. It's actually one of the largest pools in the world. And inside of it, we have a full-size mock-up of the International Space Station, and it's where we learn how to do spacewalks on the outside. And so every handrail, every path, you can commit that to memory, and you can also learn how to work in the suit. And I can tell you, when I first became an astronaut, I remember that can be really hard work, really exhausting, and you can kind of forget that it's fun sometimes. And I remember working on the outside of the space station and in the swimming pool, and I remember looking up, and I saw the reflection, and the reflection looking back at me was an astronaut. And I remember just thinking, wait, that's me. And you kind of remember what you're doing. And so for me, it was putting on the spacesuit and getting in the pool is by far the most fun thing that we can do for training.
My name is Logan, and Brooks, 5th grade, would like to ask, what has been your best experience in space, and when did you have this experience?
I've only been up here for 2 months, and so I hope that there are lots more experiences to come, and there's already so many. But I'm going to tell you about one really special moment for me that I will never forget in my whole life. And that was right after we launched. So after we launched to space, it was nighttime when we first got to orbit. And of course, we got to orbit. It was only 9 minutes after we launched, we were already in orbit. And there's a window. I was on the Soyuz space vehicle, and there's a window right next to me on my right side. And I remember kind of looking out, and all I could see was dark. And I didn't really, at the time, kind of understand what the Earth might look like. And so I wasn't really looking for it. I just remember looking out and just seeing the black window. Well, a few minutes later, I remember this glint of light catching my eye, and I saw this blue kind of spear across my window. And at first I thought it was something from our vehicle. And then when I looked closer, what I realized is I was watching my first sunrise. And when you're in space and the sun comes up over the Earth, the light, it's so fast, and the light, it just moves across the Earth, and you can see the whole curvature of the Earth. And I remember just sitting there looking out in awe. It was the first time that I got to look back at the Earth and see an amazing sight from space. And that has to be my favorite experience.
My name is Jesse.
And John. And Buckeye students would like to ask,
Does eating in space feel different than it does on Earth?
It physically feels the same. If I have a bite of food on the ground and a bite of food up here, it physically feels the same. But there are some differences. So I'll show you some of the food that we eat. There's some differences on how we have to eat, right? So I'm going to show you a couple different types of food that we have. So we have this food that comes in these packets here, the white packets, and that's dehydrated food. And so what that means is they take all the moisture out of it, and so we just add water to these type of packets. And then we have these flat packets. And these we can just heat them up, open them up, and eat them. And so physically, when the food goes into our stomach, it doesn't really feel any different. But when we pick our food and prepare our food, it's very different. And I will tell you, one of the things I did realize, you do have to be careful when you first learn how to eat in space, because you can be very susceptible to kind of choking. If you've ever gotten a little bit of food on the wrong side of your throat and it kind of feels funny, you're kind of susceptible to that because all of your fluids have shifted, and you kind of have this head heaviness, and your throat feels a little different. And so you kind of have to take it slow at first, just so you don't kind of choke yourself. But other than that, it's pretty similar.
My name is Monique.
And Isaac.
And Buckeye School like to ask what exercise do you do in space?
Well, exercise is very important in space. And not only is it good for us mentally, because exercising is fun and it makes you feel good, and everybody should do it every day, but it's also very important that our muscles and our bones stay strong. And so every day we do two different types of exercise. We do either the treadmill or the bike. So the bike is it's actually just like a bike you would see on Earth, except for there's no wheels and there's no seat. It's like a box that's got pedals on it, and we just kind of clip our feet into the pedals, and we can pedal from there. Our treadmill, again, it looks a lot like a treadmill on Earth, except for obviously we can't just get on it and run, and so we wear a harness that has big rubber bands basically that hold us down onto the treadmill, and then we can run on the treadmill. So we do one of those every day. And then in order to stay strong, and most importantly to keep our bones strong, so to protect against losing our bone density, we lift weights every day. And we have an amazing machine called the Advanced Resistance Exercise Device, the ARED, we call it. And we can do a lot of the weights that you typically see in the gym, bench presses and squats and deadlifts. And it's very important that we do that every day, not only so we don't lose muscle mass, but like I said, so our bones are loaded, because your bones are only as strong as they need to be. And so that's why it's really important that you get out and you move your bodies and you guys stay active.
My name is Jack, and Brooks students would like to ask, what are the known effects of space on the body?
Well, that's another great question, and that is actually one of the questions that we are answering every day on the space station. And so we want to understand how space affects, how weightlessness affects the body, so that we can do even deep space exploration for even longer periods of time. So we have a couple big things that we've learned. When astronauts first flew to the International Space Station, they experienced some pretty severe bone loss. And this was something that wasn't totally expected based on shorter-term flights from before. But the rate at which it happened was pretty shocking, and we knew we needed to develop a countermeasure, which is what we call our exercise, to prevent that. And so that's one of the things that we learned. That's a good story. One of the questions that we're still asking is how the fluid shifts affect your body. So, you know, I'm floating, but also all the fluids and all my organs are also floating. And so my stomach sits a little bit higher than it does on Earth. And the fluids that are normally pooled in my legs, you know, are kind of pulled up to my head a little bit more. You kind of have this constant head fullness. It's not like a headache. It's just you're kind of aware of a head fullness. You get used to it after a while. But how does that affect vision? That's one of the big questions that we're asking. Or does it have permanent effects on vision? Because if we end up going to Mars, or when we end up going to Mars, and I say humankind, when humans go to Mars, we're going to land there, and there's going to be some gravity there, and we have to understand what kind of strength we're going to have, what kind of eyesight we're going to have. We've got to understand those effects. So those are just two examples, but there's also effects on your mental state. We talk about the space fog that you have, and that could be because of the extra fluid in your mind, your blood vessels, the way your body transports nutrients, the amount of fluids in your body. All of these things change, and that is what our science teams are looking at every day.
Thank you so much for answering our students' questions today. And on behalf of our entire community, we wish to thank you for your courage and your dedication to science. I'd also like to extend a special thanks to Melissa Kaiser and each of the parents and staff members who worked to make it so our students could leave Earth today and learn and imagine about the great possibilities that lie beyond our planet. And finally, students, let's give our astronaut a big thank you.
Station, this is Houston ACR. That concludes the event.
Thank you to all participants from William Brooks Elementary School and Buckeye Elementary School. Station, we are now resuming operational audio communications.